round of applause for Mr. Peter Coffey.
Good morning to all of you. We had originally hoped that I would be able to be with you on the originally planned date of this event, as I was actually in India at about that time. When things were rescheduled, the organizers were most gracious in allowing me to continue to plan to be part of your program, even though I was not able to return to India so soon. As you probably know, we have our Dreamforce event coming up in San Francisco soon. I just finished spending 3 days in San Francisco. I'm on my way to Atlanta Monday, so being able to do this way is quite a benefit to me, to be part of this remarkable event and this very important Salesforce community. I'm going to turn off my webcam now so we can get on with the material, but I hope that you'll still be hearing me. You'll let me know if anything goes wrong. As was mentioned, I spent 18 years writing about technology for publications back when print media could keep up with this business, and when only a small subset of people with personal computers were on any network, and those were mostly local networks, not global networks. And 13 years ago, a little more than 13 years ago, I had a breakfast conversation with Mark Benioff, the CEO and co-founder of Salesforce. And since I was writing columns for an industry newspaper at the time, I wrote a column about the conversation. And so many people have trouble remembering the important conversation that changed their lives, but I wrote a column about mine, so I have it on record. And what we discussed over breakfast was the importance of not moving all of the difficulty of IT as we had known it for so long up to the internet and being content with that. You could get good returns on investment. You could cut costs by perhaps a third by taking advantage of the efficiencies of what Salesforce called on-demand and what IBM called utility computing. We weren't really using the word cloud yet. But what I said at the time is that there are so many things that are difficult to do, that are dangerous if they are done even a little bit wrong, and that no one will thank you for doing perfectly because they won't even notice. Things like security, for example. And I said, for a platform to be a service, many things that are currently the burden of the developer or the system administrator must become platform services. And the rest of us should not be doing those things anymore. And that is why this talk is titled, We Don't Do That Anymore. And as I said, and as I'll be quoting a number of authorities, doing the wrong thing better is still doing the wrong thing. So let's talk about the things that we're going to stop doing, as well as the things that we're going to be doing instead. Peter Drucker was one of the great management gurus, and it was he who I had in mind when I said, there's nothing so useless as doing with great efficiency something that should not be done at all. And there are many things that we as an industry and we as individual professionals have become quite expert at doing, and maybe even identify our value to our organization by our skill in doing those things. For example, database indexing used to be an advanced skill. And now increasingly we throw raw, inexpensive computational power at NoSQL databases and do many things on the fly with what one might call brute force techniques, because we gain so much flexibility in the use of data. We avoid the need to define all of the questions before we even start collecting the data. And the old arts of database indexing become almost as obsolete as being able to remember the numbers of the card catalog in the library. And so it occurred to me to wonder, what are the dumbest things, the most foolish things that we are still doing, and maybe even investing great effort in doing better, when really we should be saying we should not be doing these things at all? And I came up with 5, and for convenience, I found a way to make them A, B, C, D, and E. The first one may surprise you because it doesn't look like a technology statement at all. These are the short forms. I'm going to develop these in a little more detail. But the first one is assuming. The second one is bridging. The third is coding. That may surprise you. Debugging. I'm saying we shouldn't do debugging anymore. Wait a minute, I'll get there. And this last one, estimating and extrapolating. And I'm going to be elaborating on all of these, but A, B, C, D, and E, that we can remember. So let's move into this in a little bit more detail. Assuming. I've had opportunities to work with universities that were building new curriculum in management and in other disciplines. And in one conversation, someone said, "What do you think? Do we need to teach calculus in this program?" I said, "Do I get to make an alternative recommendation?" They said, "Well, what would that be?" I said, "Frankly, I think we should be teaching statistics more than we teach calculus, because I see so many engineers and managers using the calculus that they were taught to optimize their decisions based on what is really not very good quality data." We're accustomed to environments like engineering, or even, for that matter, environments like the game of baseball, where everybody knows what are the things to be measured and agrees at the end of a game how many runs were scored. We might argue over whether something was an error or not, but no one disagrees that there is a thing called errors, and we count them. But the modern era is one in which the data does not present itself to us so straightforwardly, and we need to be looking for data in unconventional places, measuring it by unfamiliar techniques, designing experiments in a way that used to be a very specialized domain. And if there were one word that could be retired from use, recently someone did a survey and asked scientists in many different domains if there is some word in their field of study that is so often misunderstood that they wish they could get people to stop using that word completely. And the phrase that came up was statistical significance. Because so many people think that significance means a large effect, when it really, as used by mathematicians, only means an effect that's probably not random. Doesn't necessarily mean it's a big effect. And understanding that difference is not something that's easily communicated to non-specialists. But Ginny Rometty, who runs IBM, was at a conference that I attended some months ago and said, you know, in a few years, participating in a business discussion and not being able to provide a data science perspective, at least at some elementary level, really, you're not going to have a lot to contribute to the conversation. We are not going to be doing accounting where all the numbers are exact and all we have to do is add up the columns. We're going to be doing experiments with the way we collect the data, the way we interpret the data, and in the same way that it used to be being a driver was a job, well, now most people feel they need a driving license to get to their job. Being a statistician was once a job, but being able to think about data this way is going to be important if you want to add value in a business conversation. Now, being a data scientist might seem like a very exotic idea. It's really not. It's treating data as a subject of scientific study. Well, what do scientists do? They form hypotheses, they conduct experiments, they are skeptical, they look for ways to reject the null hypothesis, the hypothesis that there's really nothing here. They need to be convinced that there's something there besides just random chance. It is the paradox of having so much data available to us today that we can put so many variables into a calculation that eventually something is going to correlate with something. And there are websites that show unlikely correlations. One of my favorites is that in any given year over the last several decades, the number of letters in the word that wins the national spelling competition in the United States correlates surprisingly well with the number of people who die from spider bites in that year. I don't think any of us believes that there's an actual cause and effect relationship there. It is an accident of the data. Well, now we have the power to discover many more of those accidents. We're going to have to work hard not to let those accidents mislead us. And if you don't produce results that make people angry, you're probably not producing results that are valuable. This is one example that was offered by someone who works at a website that does automobile advice called Edmunds.com, who at one point worked in our Department of Defense, which spends a great deal of money conducting scientific research. And the question was asked, does Department of Defense research spending crowd out private sector research spending? Does it consume resources that might otherwise go to industrial innovation? Or does it act as a catalyst? Does it stimulate new research? Well, people wanted to find that so-called multiplier effect. They wanted to believe that every time the Department of Defense spends $100 on research, $1,000 of other research happens. But she found a substitution effect, that they were crowding it out. It was not a popular result. And being prepared to present people with results that will confuse them, or maybe even make them angry, is going to be part of the job if you want to be contributing real value here. That was A. A for assuming. We need to do less assuming and more rigorous experimentation with numbers. B is for bridging. Traditionally, the data that runs a business originated inside the business. And so it was natural to capture it in a database and put tremendously strong protection around that database and treat the data as property and maybe even as the basis for a business model. Proprietary data collections, they were a thing. But then we started wanting to connect them. We discovered that connecting databases that were designed to be isolated and secure was expensive and difficult to do. There are new data structures in the world today that take advantage of lower cost of connecting things and lower cost of using advanced encryption to assure integrity of data and safety from corruption or falsification. Sometimes these are called blockchain, which is a special case, but in general, distributed ledgers are an object of great interest to companies like Salesforce, IBM, and others. This is important because we have seen what happens when there are large, massive, isolated collections of data that fail in brittle and catastrophic ways. The Equifax breach was a castle of data whose walls fell down. And only in this past week, Oracle was putting out bulletins reminding Oracle customers of their burden of applying patches to fix vulnerabilities that have been known for many months. Now, of course, in a modern enterprise cloud environment such as Salesforce, maintaining the integrity and security of the data is the responsibility of the service providers, such as Salesforce. It is not left to the conscientiousness or perhaps the carelessness of individual systems administrators in individual companies. We don't have to say to our customers, you really should have applied that security update. It's our job to have done that for them. And this is an important, increasingly important difference between the old model and the new. If I let you have a virtual server up in the cloud, but you are responsible for its security updates, well, all we've really done is preserve a problem instead of using the opportunity that the cloud gives us to make that problem dramatically reduced. Distributed ledgers are real. They're being used right now in financial, manufacturing, in supply chain, and the word blockchain is used so often that people think that all distributed ledgers are blockchains. Blockchain's a particular example, and it's not particularly scalable. It's not particularly fast. And my colleague Vala Afshar quoted me correctly as saying, calling blockchain that thing that Bitcoin runs on is like calling the internet that thing that Amazon sells books on. Blockchain is used to run Bitcoin. Blockchain is a special case. It could be used for other things besides cryptocurrency. And other distributed ledger technologies are going to be tremendously important for things like financial services and supply chain efficiencies. The good news is that in a pure services world like that of Salesforce, you don't need to become a blockchain or distributed ledger expert. You can use APIs to push and pull from something like our Heroku application engine to something like a distributed ledger maintained for you as a service by someone like, say, IBM, with whom, of course, you know, Salesforce has a growing strategic partnership, and they will, in fact, be the lead sponsor at Dreamforce this year. The relationship between IBM and Salesforce is going to be, I hope, quite interesting. And you can now ask yourself, looking at a business problem, should the data be stored in a traditional database model, or is this the kind of data that needs to be a shared resource, a common source of truth for many organizations, and we should not have one single party controlling that data. We should build a distributed, shared, cryptographically protected structure. And now you get to do that as a design decision without having to incur technology risk and budget risk and developing new and advanced skills. What was C? I said that coding is something we should stop doing. And this is controversial because there are many well-intentioned programs that are trying to increase the number of people who know how to code. It's important to be able to think computationally, to be able to look at a problem and see the ability to decompose that problem into algorithms and patterns and sources and uses of data. That's not identical with writing the code to do those things. Well, you can be a very good driver and not know how to drive a stick shift. In fact, Formula One racing today, increasingly the car's gear shifting is done by a computer, which allows the driver to be thinking more strategically about things like the best line through that curve. Writing code is a way to create new failure modes, and that is a new observation about a very old problem. Even COBOL was able to have very costly failure modes. And Mark Andreessen, talking about what the platform needs to be, said back in 2009, 8 years ago, that the last thing you need is to have all of the burdens of building and running the application being on the developer. If there's a bug in code, then finding it and fixing it is completely the developer's problem. But if you have ever had the misfortune to create an infinite loop in Apex code on Salesforce, you know that the platform is able to warn you that you have created a piece of code that will burden the shared resources and will not produce a result, and it points at that line of code and says, this is not something you want to do, you need to fix that. This is what a runtime environment is, where the platform handles these things. These level 3 platforms are hard to build. There are very few examples. I can think of one, namely Force.com. It's difficult to come up with an example of something that does that much for you. And you may be familiar with something Arthur Clarke, the science fiction writer, once said about any sufficiently advanced technology is indistinguishable from magic. Well, someone did a very simple transformation on that statement. It said, well, logically, that means any technology that is distinguishable from magic is insufficiently advanced. And to be quite candid with you, the only reason I took the job I have now 10 years ago is that I actually did believe, and I have felt pretty good about it since then, that we really were building things that were not distinguishable from magic. I have had many developers come up to me in great surprise and share with me stories about things that our platform had done for them that they never expected a platform to do without being told to do it, that they've been protected from their own mistakes in ways they found really quite extraordinary. What about D? What about debugging? How could I possibly say that debugging is a bad idea? Well, the problem with the way we talk about debugging is that we treat code as if it's, like a perfect object, like a diamond that we want to polish and to make completely flawless. But the environment in which code runs changes so rapidly today that the definition of wrong is continually changing. We need to be thinking of it not as polishing a perfect gem, but as playing a game, as game theory, where you have incomplete information and you are working against an active opponent. That's the technical definition of game theory. And build systems that are resilient instead of trying to build systems that are perfect. Let me give you a very simple example of what this means. If I said, here are two systems, one of them fails about, on average, once each year, the other one fails 1,000 times every day. You might say that the first one is obviously better. Let me finish the thought. One of these systems fails once each year. When it fails, there's catastrophic exposure of sensitive data, and the system is inoperable for a month. The other system fails 1,000 times a day, but the failures are detected in a microsecond, do not result in data breach, and there is no noticeable interruption in service to the end customer. Well, the second one is clearly a far superior proposition. That's what resilience is. And building systems that anticipate constant change in the threat environment and constant change in the expectation of what they will do, that's the direction we have to be going. That's not the way we teach coding and specifying and debugging systems. We teach it as if these things were almost laboratory experiments. We have to change the way that we approach the design of systems for these more complicated and more constantly changing environments. Then there's E, estimation and extrapolation. We're accustomed to the idea that market research is expensive to do and produces approximate answers. We see the occasional story of a visionary like Steve Jobs who would say, the customers won't know what they want until I show it to them. Peter Sondergaard at Gartner said, the old research asks people, what do you want? The new research measures what people seem to be trying to do. And if you can focus on the problem that people seem to be trying to solve instead of asking them what they think they want to do to solve it, genuine creativity can result. Daniel DeBow said when he was with us at Salesforce that if you want to have one brilliant success, falling in love with your brilliant solution to a problem may produce one amazing result. But if you want to have a steady string of amazing innovation, you can't fall in love with your solution. You have to fall in love with the problem. Let me give you a very simple example of what that could mean. Michael Porter at Harvard Business School once said, no one ever wanted to own a 3/8" drill bit. They just wanted a 3/8" hole. Now, if you make drill bits, you may be really proud of their durability and their cutting performance. What a great job they do drilling holes. But if you forget that the customer doesn't want to do drilling, the customer just wants the hole, then someone who comes along with a whole different technology, like using high-pressure water jets to make holes, which is used in some forms of manufacturing now, because it produces a much cleaner result and has many superior characteristics with certain materials. Well, if you think your product is drills, the guy with the water jet is your competitor. If you think your product is holes, then a new way of making them is something you can embrace. And culturally, in an organization, thinking about this is going to be important. Measurement is important. It's important because market research spends too much to mislearn results. People are not reliable reporters. This is an actual error message from an actual piece of software. I want you to imagine being on the telephone in the call center, having to deal with someone who has this error message on the screen and saying, so what's on the screen right now? They're not going to feel very good about having to report this to you. In fact, I showed this slide once and someone raised their hand and said, I know the developer who wrote that error message. He didn't last very long. People are not reliable reporters of what went wrong. And today we're working with increasingly complicated systems. Consider what an iPhone is compared to how much simpler things were when you ran a computer by pushing a floppy disk into a slot, running one program, and when you were done, pulling that disk out and putting in another. There wasn't a lot of complexity to manage. Now, of course, there is. Here's the other problem. People are trying to get their job done. They're not trained like test pilots to notice small irregularities before they become catastrophic failures. Some of you may be familiar with an exercise called Gorillas in Our Midst that was reported some years ago, where people were shown a videotape. They were instructed, count how many times the players in white shirts successfully pass the basketball to each other, and then they run a few minutes of videotape and people are tossing the ball around. You're told, count the number of times that someone in white successfully passes the ball to someone else in white. At the end of the video, you're asked, did you notice anything out of the ordinary? Almost no one notices the gorilla walking through the picture. All right, it's actually a man in a gorilla suit. Many people not only don't notice, but when you then show them the video again, and they're not concentrating on the ball, they become actually angry and say, there is no way that I missed that. They did miss it, because that's not what they were trying to get done. This is one of the reasons why we need to take data directly off of products and directly off of processes if we want to get good results. And finally, we get statistical significance from having so much more data available. This is data on how long people stayed awake after an earthquake in Northern California that was taken off of Jawbone fitness devices. Thousands of people with accurate information known within a few hours of the event. Compare that to what it would have taken to learn this kind of thing inaccurately and after a great delay by conventional research techniques. There are so many things now that we'll be able to do statistically significant analysis essentially immediately and with tremendous accuracy compared to asking people these questions. We have to think about it, and we have to go looking for it. Kevin Kelly at Wired magazine commented on his frustration when people would say things like, I wish I'd been around at the ground floor when the internet was getting started and all the really good things were still being invented, because now it's just, what color is the new iPhone? He said, you're just not thinking clearly about this. 30 years from now, you're going to be using things that were only invented 20 years from now. And you're going to be saying, how did we ever get along without this? And people will be saying 30 years from now, if only I'd been around in 2017, when there was hardly any AI in anything yet, Apple had only barely begun to sell a watch that could work without a phone. That was a brand new idea back in 2017. Wish I'd been around then to start really doing the cool things you'll be able to do. The reason to make stuff digital is to make the data computable and transformable. And we're just beginning to redesign businesses around that. For example, look at Uber. Uber looks like an easier way to call up a cab. But if you know anything about economics, you know the phrase consumer surplus. How much money would people spend over and above what they are being asked to pay? That gap is consumer surplus. It's always been a conceptual idea among economists. But Uber, because of surge pricing, has data on what price will make people say, no, I'll wait and buy that ride later on when it gets cheaper. Almost never before in economic history have we been able to measure people's resistance to a momentary increase in price. This is a whole new way to think about the economics of transportation. And the stuff that you think is cool today, 30 years from now, we're going to look at that the way today we look at a 1984 Macintosh, which certainly has a few good ideas in it, but it was hopelessly slow, hopelessly limited, barely the beginning of what we now expect in terms of user interface and intuitive ease of use and performance. And it's difficult to convince yourself that we have that much improvement still taking place, but it may not even take 30 years, it may take more like 3 years. That's what exponential growth is. If you go back and look at some of the articles on the first iPhone 10 years ago and realize what a limited device it was, no app store, no software developer kit, no camera, no ability to multitask or copy things back and forth between applications. And it was really very expensive for how little it did. But it was clearly the beginning of an idea, and the speed of changing the world in those 10 years has really been quite remarkable. Let's zoom out for a minute and talk not about technology, but talk about how people live. You heard the phrase the Salesforce economy, and it bothered me when I heard it because it was just quantities. It was how many jobs, how much gross domestic product, and so on. And it made me think about this word, economy, and what it really means. It turns out that it goes back to a Greek word that means the manner of running your household. And I thought, you know, the economy we have now, I call it the uh-oh economy, because when something goes wrong, someone makes more money by making the mess go away. And so if I make $1 million making a polluted mess and someone else makes $1 million cleaning it up, we call that $2 million of gross domestic product. $2 million of economic activity. It all looks good. And I think we feel at a gut level that that's really not right. The traditional economy is one in which if you're distant from other people, you're protected from their competition. If you have large capital investments like factories, you're protected from competitors who can't match your large investments. If you have communication power, you can buy large advertisements, and the customers cannot compete with your communication power. Well, you wind up with a lot of power that the customer does not share. We've talked about this phenomenon of data in silos and people owning data and lengthy delays in processes, things like buying and selling securities on financial exchanges that may take 3 days to settle. With distributed ledger techniques, that goes down to more like 30 seconds. We have transactional relationships with providers. Every sale takes place in isolation. They don't really understand patterns by which an entry-level customer today becomes a much more profitable customer tomorrow, and maybe even becomes a brand ambassador. They don't measure the behavior of customers over a long period of time. They just record individual sales. And the way we think about our employment and our careers is very specialized and very narrowly defined. You are your box on the organization chart. You are the list of things you studied as a student 20 years ago. I think we all understand these are not the models that we want to follow going forward. And of course, at Salesforce, we don't say, uh-oh, we say, ohana. We talk about constructing a family intentionally, not just of people to whom we're related, not just people who work for us, but also customers and partners, and really including them in a larger community. Customers and citizens and contributors are going to be operating in a world where they have global access to knowledge, where you don't just look up information on a website, you invoke an API that applies that knowledge for you, executable knowledge, where there are not barriers of capital. Everything is a scalable service. I can begin manufacturing a product as soon as I ship my computer-aided drawing files to a flexible manufacturing facility like Foxconn or Flextronics. There are open platforms of communication. Customer communities can talk about a brand without the permission of the owner of that brand. In fact, this redefines what a brand is. Chief Marketing Officer at Coca-Cola once said, our customers own the brand, we are just the stewards of that brand. And that when we need to live up to the customer's expectations. Truth is going to be a shared thing. You won't have central control or reliance on a central authority for databases. Data will live in shared, trusted structures. We have the data now to have a journey relationship between a vendor and a customer. I can walk into a store and they know when I bought a product. They can offer me discounts on repairs and replacements. They know the next thing I'm likely to need. I walked into a camping equipment store once with a trekking pole, a pole for climbing on steep trails that had broken on Mount Whitney. Not only did they immediately offer to replace it, but they did point out that it had been purchased on sale by my wife a few years earlier, so they could only credit me with the sale price against the new one. I didn't have to produce any documents or receipts or anything. They took responsibility for knowing that. And the way we're going to think about careers, when we work for many more years in environments where knowledge changes many more times during your career, you're going to have the equivalent of several college educations over the period you work. And so your relationship with education is not going to be purchasing a diploma, but subscribing to a continual service, a continual refreshment and update of your knowledge, working across many boundaries that we used to think were quite separate. I work with one university on their big data program, and when I first met with them, the faculty members they had waiting to speak with me included mathematicians, computer scientists, business school professors, and faculty from their School of Visual Arts, because they had accurately understood that the compelling visualization of data is much of its power to change people's minds, to change people's behavior. So I began with a Peter Drucker quotation. There's nothing quite so useless as doing efficiently what you shouldn't do at all. A related idea is that if you want something new, you have to stop doing something old. If you treat the new thing as an experimental project and keep the old thing running side by side, many people will not make the adoption effort. You will never find the things that need to be improved in the new system, and it will always be a pilot project. The explorer Hernando Cortez is said to have told his men when they landed in North America, we're going to burn the boats because we are not going back. And that sensation of telling people, we are stopping this old thing. You have 30 days to find out what the new thing can't do so we can get it fixed. But 30 days from now, we're going to be running on the new thing. We're doing a little bit of that with Lightning right now. I'm not completely comfortable with it, but I understand why it's necessary. And that leads to this last Peter Drucker statement. Management is doing things right. Leadership is doing the right things. Andrew Grove, when he was running Intel, said, I can't afford to pay someone the salary of a manager if all they are being is a supervisor. A supervisor makes sure you're doing what you're supposed to do because you've always been doing it, and make sure you're doing it right. A manager is a leader who develops your ability to know the new things that need to be done. And I hope that what I've been able to share tonight is a vision that these facilities we have, the connectivity, the computational power, the ability to discover each other's talents and build collaborative networks, these are not an opportunity to lower the cost of doing what we've always done. They are an opportunity to recognize things we never could do before that solve problems, in many cases, that we thought we were just going to have to tolerate, as if they were friction or rust or gravity. And instead, we can start to regard them as opportunities for dramatic change. So what are the dumb things we're doing? We're assuming and optimizing, we're bridging, we're coding, we're debugging, and we're estimating. We should be assessing and adapting. We should be building chains instead of isolated fortresses. We should be looking for chances to compose powerful services and to build resilient systems using a point of view that looks more like game theory instead of traditional debugging. And we should be measuring and modeling the world around us instead of using old and limited and inaccurate research techniques that always have us skating to where the puck is just about to leave. And that's what I had for you today, and I really appreciate the chance to be with you all. Congratulations on the event. Congratulations on coming together to show people what an important community this is. And I'm so pleased that I was able to be part of it today. Thank you.